Hey everybody, welcome to the Hitachi compressor repair part 3. And in part 2 I had quite a few good comments left on the video, and I'd like to just do a general thank you to the several people who commented on the videos, noticing my problem with the clearance over here between the side of the compressor when it's mounted here and the switch. And they hit the nail on the head. And you know, I hadn't looked at the compressor until today because this new switch came in, and I had already ordered the switch before I had read those comments. And now when I look at the compressor, I just am baffled by how I missed it. But it's clear to me now that absolutely what had happened was this compressor either took a tumble, fell off of a truck, fell off of a roof, fell off of something, or had something very heavy dropped on it at some point. And what ended up happening was, in addition to that little bracket being broken that I showed in the previous video there, the one that was over the start capacitor, in addition to that, this whole assembly basically has been bent downward. And not only is it bent down further than it should be, it is also bent that way. So when I eyeball it from here, you know what? I'm going to change the camera angle and I'm going to show you guys. All right, so here we are. Actually, that's not quite accurate because of the weld bead here, but if I kind of compensate for that. So you can see that that thing is going out that way quite a bit. The gap here is a lot smaller than the gap there. That's just left to right. In fact, as if that wasn't bad enough, there's clearly a huge dent right here on the underside. So when this whole thing got stoved, pushed down, it actually caved the tank in right here. So it's kind of hard to see probably on the video, but by putting my finger in there, you can see it goes down into a little dip here. So that's really something else that took that big of a biff. I'm also wondering whether or not right over here, if this isn't a little bit of a dip. Well, no, that's underneath the original paint color, so that hasn't been re-welded. But there's right here this discoloration. I'm wondering whether or not that isn't corrosion because of maybe that weld right there has separated from the tank. You know, I didn't even check to see if there was a leak at that point. It was leaking so badly here, I kind of ignored this. Now I know why I didn't bend it back before when I first broke it. And I'll tell you another thing, it doesn't really matter, because here's what I would have to do to properly fix this. If I just pounded on it or put something on there to give me a whole lot of leverage and bent this back, all I'm going to do is fatigue this metal right here and cause a weak spot. Okay, so I would probably have to I'd probably be better off cutting this off, welding a little gusset plate on here, and then welding this nipple back into the plate. Completely doable. I mean, it'd be easy enough to make a little plate and weld that on there. But as luck would have it, fate has intervened. So literally, like the day that I finished that last video on the compressor and ordered that replacement pressure switch online, I'm driving down the road. I barely get 1,000 yards from my house, and what do I see out by the curb but this DeWalt compressor? And I was like, boy, the fact that it was so close next to the road, you know, out with the regular rubbish, I was like, oh yeah, they're throwing that out and they're just waiting for the scrap metal guys to come by and snag it. They figured, like a lot of people do, that if you leave it by the side of the road, somebody will come along and take it if you want to get rid of it. So I jumped out of the truck, took a quick look, and realized, oh yeah, there's a good reason why this thing's in the trash. So what we got here is we got what's left of the pressure switch, which even if this pressure switch was good, it suffers from the same problem as the last one. Cover's gone missing. And the cover will cost you, actually, the original cover on this thing will probably cost you more than a generic switch, complete switch. So that's a no-brainer. We don't bother with that. That's issue number one. The cord is cut off. That's issue number two. Look at the compressor. Look what's going on here. They took the whole shroud off. I guess they wanted to get a gander at what was going on inside this thing. Oddly enough, the motor's not seized up. But look at this design on this compressor on this thing. There is no oil. This is an oilless compressor. And the way I know that this isn't like it's missing something that's supposed to cover this and be filled with oil, well, the belt's right here. It's a belt drive, so of course it's not an oil deal. So, what a piece of garbage, I think. You know, I don't know. I guess maybe some people might think, oh no, oilless is better because you don't have to worry about air infiltration into your oil infiltration into your air. You get cleaner air. Well, I mean that's real important for certain jobs, but so anyways, so look at this. They even cut the hose. So oddly enough, there was a fitting. There's water in there now. We've had some rain. Oddly enough, there was a fitting in here. I'm not sure exactly. Must have come over to probably here. Probably was a copper line. Oh, somebody grabbed the copper line off of it for scrap. I mean, that's the only reason I could think of why they would bother tearing it off. But anyways, so why did I take this thing? I took this thing because I took one look at this little cart and frame that it's on, and I thought, hey, that's pretty snazzy. I figured, A, you know, maybe, even before I found out that my tank system down there is not going to be worth pursuing, I was already thinking, hey, maybe I would rather put my compressor on this cart and use this tank. This is a larger diameter tank. I'm going to check. I'm going to compare the volume just to see how much I'd be losing or gaining by going with this tank. Because originally I was thinking, well, maybe there'd be some way I could bolt the additional tanks on there and tie them into that tank and have even more volume. But now, of course, with that other tank being all bent up and everything, and being of questionable, you know, integrity, I think we'll just completely abandon the idea of using those tanks at all. Those would be scrap metal. So, okay, so yeah, so it's on this roll-around cart, which is really kind of spiffy, and it's got this handle that comes out. So you pull the handle out like that, and it rolls around like a hand truck. So how cool is that? So, couldn't leave that by the side of the road. All right, so I did a little research just out of curiosity and got some statistics here. So this is the Hitachi, the EC12, weighs in at 60 pounds. It's got a 14.5 amp induction motor. It's got a cast iron oil lubricated pump. It's the 4-gallon twin stack tank. And then it goes on to say it's a 14.5 amp 2 horsepower. It delivers 4.1 CFM, that's cubic feet per minute, at 90 PSI. All right, so I actually found a PDF file of the owner's manual and went to the specifications page in there because I figured that's straight from the horse's mouth, whereas the other information I just gave was off the Amazon site. So input, 2 horsepower, 1.5 kW. Current, 9.5 amps. See, that's interesting right off the bat. That's lower than what they're claiming the amperage was on the Amazon site. Tank capacity 4 gallons, at least that matches up. Maximum pressure is 125 psi, and maximum CFM is, let's use at 90 psi for our benchmark, is 4.8 psi or 5.1 depending on which model this is. I'm never going to know exactly which model this is. I think this is an EC12 though, which would be 4.8 CFM. So let's see how that stacks up against that DeWalt. I can tell you right now, this thing is pretty heavy. I just toted it down the stairs. I I'm pretty sure this is a DeWalt model D55146, based on the fact that that is the only model I can find that has this exact same configuration, where it's got the wheels and it's got the almost like a dolly handle on it, so you can roll it around. They're calling this a 1.6 horsepower continuous, 200 psi, 4.5 gallon compressor. So the tank's a 4.5 gallon tank. That much we know. The 1.6 horsepower continuous, that may be on par with that supposed 2 horsepower over there on the Hitachi, because on the Hitachi they're not saying it's continuous, so that might be some sort of a peak horsepower or something like that they're getting out of it. The interesting thing is they're calling it a 200 psi, but then in the features it says it's a 200 psi max tank storage pressure, provides a user with 80% more usable air than the industry leader. It doesn't say that this thing's necessarily set to actually shut off at 200 psi. It does say 5.0 SCFM at 90 psi. Okay. It says that it's much quieter. Of course, that's not going to be the case anymore, because part of the reason why it was so quiet was supposedly that compressor design, which we're going to be scrapping. This is interesting. It says 10-inch non-flat foam tires. So those are almost like run-flat foam-filled tires on there, according to this, which I like that. I've got small wheels like that on like one of my generators, and it stinks when they get a little bit soft, because if they get soft, it's harder to roll it. Oil-free, maintenance-free pump for convenient use. Yeah, we saw that already. It talks more about the motor and the pressure. None of that's going to be important for us. And then it's funny, it says all of that in the features, and then when you scroll down, this is on the DeWalt website, when you scroll down to specifications, it says CFM. Okay, yeah, CFM at 90 psi is 5.0. It's belt drive. Horsepower 1.6. Shipping weight 90 pounds. Tank size 4.5 gallons. That's mainly what I wanted to know, was the tank size. Tool weight 83 pounds. Huh, that's interesting. So I think the first thing I'm going to do is I'm going to take this old compressor from this DeWalt off of here. Get it out of my way. Well, I'll probably throw a cord on it and fire it up just to see if it runs, just out of curiosity. So it's kind of interesting where they get this mounted. It looks like there's like one bolt here you loosen, which undoes this clamp, and then I think that allows this compressor to move this way far enough to unhook from these metal tangs that stick out over here, and so the whole thing just comes off by loosening one bolt. That's kind of neat. All right, so I got this off. It was just loosening that one bolt, and it would have been really easy, except that the cover actually gets in the way. So if you were actually taking one of these models apart to work on it, you would definitely want to take this plastic cover off before you take the compressor off. But I was having a really hard time trying to get these screws out. This one's actually broken off. These two over here, they're really deep recessed Allen head screws. So rather than mess with that, I just pried the plastic out of the way with a screwdriver so I could work that little bolt head, shift this out of the way, and the whole thing just drops right off. So I got the compressor off now. Take this out of the way for a moment, because I want to talk about what I noticed on this compressor is that I can't find out where the unloader is. There's no little small line coming from the pressure switch going over to this unit right here is the check valve, and the check valve in my Hitachi is right here, and you can see that it's got provisions for the unloader line to come over to here. And what the unloader line does is when the compressor reaches pressure and the pressure switch shuts the power off to the motor, the unloader line opens and releases pressure that may be in the cylinder, so that the next time that the compressor needs to start, it doesn't have to try and overcome the pressure in the cylinder from having the piston come up. In other words, if it happens to stop and the piston's at the bottom of the stroke, for instance, and that cylinder is pressurized, you can imagine it's going to take a lot of startup torque to overcome that when it first starts. If there's still pressure in there, you know, it's going to kick on, say at like 85 psi or whatever you set the cut-in pressure on the pressure switch. Well, it's going to overcome that 85 psi of pressure before it can move the piston up on the first stroke. So to correct for that issue, this unloader valve opens and releases that pressure in the cylinder. So, and then the check valve is what keeps the air from coming back out the tank and going out the open unloader valve as the unloader valve. So when you shut the compressor off, you've probably heard this before, when you initially shut a compressor off, there's a brief psh sound, that's the unloader doing its job. And it only lasts for a second because it's only unloading the air pressure built up in the line, the pipe coming from the check valve over to the compressor itself and the cylinder itself. Once that is released, then it stops flowing. And if you continue to hear air flowing, more than likely you have a bad check valve. So, this is the check valve. It has no provision. So I don't know whether or not this is not supposed to have an unloader. Maybe the design of this compressor is such that it's able to overcome that additional resistance of air in the cylinder. Not sure. So for now, I think what I'm going to end up having to do is I'm probably going to end up, because I'm going to use the Hitachi's compressor, and the Hitachi's compressor by design needs to see an unloader valve. So I think what I'll probably end up doing is taking this check valve out of this tank, and I'll have to get a bushing and install this check valve, which has the port on it, to have the small line go over to the unloader. Oh, now I know why I was having such a hard time with those screws. They're Torx head. So this is a direct induction motor design on here, so it's actually got brushes on it. Well, the windings aren't all black, so the motor didn't burn out. Oddly enough, this actually looks like it should run. Alright, I just wired up a cord quickly, and let's see what happens. Well, forgot to account for the high startup torque. It sent the thing. Yeah. The high startup torque sent the compressor flying off the bench. It hit the floor and it shattered the fan on the back of the motor.